radical is. When we are talking about radicals, there are three things you will hear me say.
What? My bad.
Excuse me? Oh, okay.
What?
All right. Going back here. First thing first, we have the radical sign. So
What?
it's going to look like this. It's having two
Yeah.
numbers. The number that goes under the radical is what we call the radicand,
I don't
and the
know. Just
number
Pepperjack.
here is called the index. Now, what do we mean by radicand and index? The index is telling you what root you're taking. So sometimes we are taking the square root of a number. Sometimes we take the cube root of it, fourth root, and it could be any number greater than 2. So it starts from 2, goes all the way up. The radicand is the number that we are taking its root. So we break it down into factors, we take its root. That's what we call the radicand. Now it says this is a symbol that we use for square root, and the integer could be any number that is 2 or greater. Another thing that you're going to see a lot, if your index is 2, you're just going to write the radical sign. You don't put the 2 here. So anytime you don't see anything, that means the index is 2. For other ones, you are going to write down the index. Now it says roots or radicals are the opposite operation of applying exponents. We can undo a power with a radical, and we can undo a radical with a power. Now this is what we mean by this part of the package. It says, let's think about 49. So when we are having a 49, if you take the square root of it, it's going to be equal to 7. Now, if you raise that 7 to a power of 2, you're going to get 49 again. So taking the square root and raising it to a power are going to be the opposite of each other. You take the square root, you go from 49 to 7, you raise it to a power or exponent, and it goes from 7 to 49. The same thing from negative 27, you go to negative 3 if you take the cube root. If you raise this to a power of 3, like here, you're going to get negative 27. Now, with this part, there is an important thing that we'd better cover right here. When you are working with radicals, it's important if you have an even index or an odd index. So when we are having an even index, let's say square root or the fourth root or the sixth root, you have to be careful with your radicand here. In cases of even indexes, you can't have a negative radicand. So for example, if I'm having a square root of negative 49, this one is not going to have a real answer. You can do something with imaginary numbers, but it will not be a real answer. So the radicand cannot be negative, and also your answer cannot be negative. So when you are taking, let's say, square root of negative 7 squared, for example, when you are canceling that power of 2 and the radical, you can't just say this is equal to negative 7. We are going to put this in an absolute value. The answer we get is going to be 7. So for even index, radicand can't be negative. Your final answer can't be negative. They must be positive. When you're having an odd index, so let's say you're taking the cube root or you're taking the fifth root, we are not going to have that limitation. You can have whatever number you want as your radicand, positive or negative, and if your radicand is negative, so let's say negative 27, the answer is going to be negative. So cube root of negative 27 is going to be negative 3, just like here. So that's a little thing that we are going to be careful about. Again, we might see it in the examples. We'll talk about it more. So far, is there any questions with page 1?
So you said yes. So you said when it's odd, it can be even or positive.
So even basically refers to like 2, 4, 6, even
Mhm.
index. we say for even index radicand. So this number that you have under your radical can't be 0. So let's say square root of negative 49. You can't answer this. It won't have a real answer. And also, the answer, the final answer, can't be negative. So similar to here, if you're taking the square root of negative 7 squared, after canceling the power and radical, instead of saying the answer is negative 7, you would say the answer is 7.
Right, but when you said when it's an odd number, it could be a negative or a positive.
Exactly. For
Okay.
odd, you can do whatever. So
Okay.
that one. And if it is positive, now for the cube root of 27, it's just going to be 3. So the odd ones are easy to work with. We have to be careful with even index. Now moving on to operations on radical expression. So operations, we put them in two groups. We have addition, subtraction, and then we have product and quotient rules. So basically addition, subtraction, or multiplication and division. For adding or subtracting, again, these two are going to have two different requirements. If you want to add or subtract radicals, you have to make sure that they are like radicals. Like radicals are exactly the same. It means they have the same radicand and they have the same index. So for example, if I'm having a square root of 5 and 2 square root of 5. If I try to add or subtract these two, I can do it. Why? Because they are both square roots and they are both having 5 as the radicand. So the way you're going to do it, you will just write down your radical, square root of 5. Now add the numbers in front of them. So the coefficient for this one is just a 1. And the coefficient for this one is a 2. Add 1 and 2, you're going to get 3. Now, if I try to do, let's say, square root of 5 plus a cube root of 5, in this case, you can't really answer it. Why? Because now they don't have the same index. They are not like radicals. That's something that you are going to be doing. Another thing that you have to pay attention to is this part. If you have square root of a plus b, you can't just separate it into two radicals. You can't say this is square root of a plus square root of b. The same thing applies to a minus b. For example, in this radical, we say square root of 9 plus 16. This is equal to square root of 25. Your final answer is 5. Now, if you make a mistake and write this as a square root of 9 plus square root of 16, this one will be a 3. This one will be a 4. Your final answer is 7. It's not 5 anymore. So be careful not to separate these ones.
What?
But if you are moving to products and quotient rules, so multiplication and division, the only thing we care about here is that they have the same index. So as long as your two radicals have the same index, you can multiply them, you can divide them. The way it's going to work out, we say, let's say I have square root of 2 times square root of 3. They have the same index. Now, the way I'm going to multiply them, I draw a big radical sign, multiply my numbers under it. So 2 times 3. It will be square root of 6. So in this case, you can actually break a big radical sign into two separate ones. We couldn't do it with addition or subtraction. We can do it with multiplication and division. The same thing with division. Let's say I have square root of 25 over 16. I can break it into two separate ones. So square root of 25 divided by square root of 16. This becomes a 5. This becomes a 4. The opposite of it, let's say we have square root of one number. Let's say 24 over square root of 6. Now, in this case, because they are not completed squares, you're just going to say, draw a big radical sign, divide 24 and 6 under it. This becomes the square root of 4. Square root of 4 is equal to 2. So as you can see with multiplication and division, we have more freedom on what we are going to do. With addition and subtraction, it's very strict. Make sure they are like radicals. If they are like radicals, then you're just going to add or subtract their coefficients or those numbers in front of them. That will be your answer. You can't break big radicals into smaller ones or the opposite of it. It's not going to work. With multiplication and division, you can do whatever you want as long as you have the same index. You can write them as two separate radicals, or you can actually write them as one radical. And for this part of it, if you read it, so it says square root of a, nth root of a equals b. If we want to rewrite this a little bit and basically get rid of this radical sign here, we can raise both sides by a power of n. If you remember, radicals and exponents undo each other. So if I do this, this power of n and this radical cancel. A will be equal to b to a power of n. This is what it says in this part. And then in the next two lines, it says if n, the index is even, a is non-negative, so again, your radicand can't be 0, and b, which is your answer, cannot be negative either. If it is odd, then we don't have any problems. All right, so any questions about addition, subtraction, multiplication, and division?
When we're at the top right there where you wrote one a square root of 5 plus 2 square root of 5,
Yes.
isn't the square root always 2 like by default?
Yes. Well, what you're talking about is going to be the index here, right?
Yeah.
So that's right. The index is going to be 2 here. Now, what happens is that they are wanting you to add them here. Because they want you to add it here, you're just going to write it down. The square root of 5. Add the 1 and 2, it becomes 3. If you're talking about this part, this is just a completely different example. It has nothing to do with that.
So what do those numbers 1 and 2 mean in that top equation? Like, is that like timesing the square root?
Yes. So sometimes you're gonna see, for example, just the radical sign here. So let's say square root of 2. This means you have only one square root of 2. Now, if I give you 6 square root of 2, that's right. This is basically 6 times the square root of 2, that we just write it that way. Now, when we are doing the additions, we have to add or subtract these numbers.
Oh, okay. So you could add those two.
Exactly. We don't add the radicals. The radical stays untouched. Whatever you're going to do is going to be with these numbers. 6 and 7, it's going to be 13.
Okay.
This is what happens with addition and subtraction. Any other questions about these operations?
But when you're multiplying, you can just add the numbers. You can just multiply the numbers in the radicand if the power is the same.
So when we are doing the multiplication, let's say we have 6 square root of 2 times 7 square root of 2. Now, in this case, there are different ways that you can deal it. You can start like writing this just as radicals, do the multiplication, or another way that also works. You can say this is like 6 times square root of 2 times 7 times square root of 2. Basically, you're all having multiplications here. So what you can do, you can multiply 6 and 7. So it's going to be 42. And you can multiply your radicals separately. Again, you're going to draw this big radical sign. 2 times 2. It will be 42 times square root of 4. Now, in this case, square root of 4 is equal to 2. So it will be 42 times 2, which gives you 84. So you're going to see it can happen in different ways if it doesn't have any of these numbers, like square root of 2 times square root of 2. Just multiply these. If you have those two numbers, you have to multiply them too. Again, they can be shown in many different ways with radicals. You have to just see which one of these you have. And then moving on to radical expressions. Again, we have some exercises here, so we'll talk about it more. For radical expressions and rational exponents. So when you have a radical, you can also try to write it as an exponent. It says if you're having nth root of a, and m over n is a positive rational number reduced to lowest terms, and n is greater than 2 in an integer. So basically what it means that you have nth root of a to a power of m. N is going to be your index. A to a power of m is going to be your radicand. You can rewrite this as an exponent. You just have to put a here. Draw the fraction line. In the top, you will have the exponent of your radicand. So the power goes in the top. The index goes in the bottom. A to a power m over n. Now, if you're having nth root of a, again, you're going to write down the a here, draw the fraction line. The power of a is a 1 in this example. The index is an n. So a little bit of example for this one. If I'm having, let's say, the cube root of 7 to a power of 8. If they ask me to rewrite this as an exponent, I'm going to say this is 7. In the top, I have the power of 7. And the bottom, I have the index. So it will be 7 to a power of 8 over 3. You can sometimes use this for some simplifications. And let's move on to the last two parts, radical conjugates and rationalizing denominators. So far, we were talking about how to work with radicals, how to multiply them, add them, rewrite them. Now we are going to talk about the times when we have to get rid of those radicals. So first thing first, you need to know about radical conjugates. Conjugates are basically the terms when you have the exact same terms just with a different sign. So if you are having square root of a plus square root of b, the conjugate of it is going to have the same terms. It's going to have a square root of a and square root of b. Now this one was addition. This one will be a subtraction. So plus becomes minus. These two are considered conjugates. When we multiply these conjugates, so this case, your final answer is going to be your first term squared. So in this case, it will be square root of a squared. There is always a minus here, and then the second term squared. So square root of b squared. And then when we try to simplify these, powers and radicals cancel. So you're going to have a minus b.
Mm.
But again, be very careful.
If
This must
something's
always
being
be
the
a
power of
minus. If
2,
you put a
and if
plus,
you're
it's
taking the
not going
square
to
root.
be right. And the final part is rationalizing denominators. Before I get started on that, is there any questions to this point? Did everyone understand what conjugates are? How we multiply them?
Yeah.
Anything that might not be very clear?
Not really.
Okay,
It's fine.
we'll probably work on some examples too. Again, if at any point you feel like you don't understand, just interrupt me, ask me questions. I don't really mind, okay?
Uh,
All right. So for rationalizing denominators, this is the last part of it. You're going to say rationalizing happens when you have radicals in the denominator. So when we have a radical in the denominator, normally we try to get rid of it. And there are different ways that we can do this. In this case, let's talk about just square roots. So let's say we have two different conditions. In the first one, you just have a single radical in the denominator. So let's say we have 5 over square root of 7. In this case, if I want to get rid of this radical, I say 7 needs to have a power of 2. Right now, it just has a power of 1. So I'm going to multiply this by the exact same thing. Square root of 7, square root of 7. Again, you have to multiply both the numerator and denominator. When you try to simplify this, it becomes 5 square root of 7. This is multiplication of radicals. Draw a big radical sign. 7 times 7 is going to be 7 squared. Now at this point, the power and radical can cancel. So you are going to have 5 square root of 7 over 7. Just like that, by multiplying it, we got rid of this radical sign here. Again, what you wrote down here is the equivalent of your original expression. So you didn't change anything. It's still correct. Now, let's say you are having a cube root. So 11 over cube root of, let's say, 2. Now here 2 has a power of 1. It needs to have a power of 3 to cancel the radical. So multiply this by a cube root of 2 to a power 2. When we are doing this, in the top, we are going to have 11 cube root of 2 to the power 2. Down here, again, you're multiplying the radicals. Write down a big radical sign. Multiply 2 and 2 to the power 2. This becomes cube root of 4. Down here, you're going to have the cube root of 2, add their powers, 2 to the power 3. The power and the radical will cancel, and this will be your final answer. So depending on what the index is, you might have to multiply exactly by the same thing or the same thing just with a power of 2. This is when you're having a single radical in your denominator. if they give you an expression, you have a radical plus or minus something else. So let's say I have 2 here, square root of 3 minus 8. Now, in this case, I can't just multiply by a radical. I have to multiply by its conjugate. So if you remember, the conjugate of this is going to be square root of 3 plus 8. When I multiply these conjugates in the top, I'm going to have this expression. In the bottom, square root of 3 minus 8, square root of 3 plus 8.
Why did we change the sign again? For the 8 positive?
It's a very good question, and you're going to see right now what happens. 2 square root of 3 plus 8. So if you remember from multiplying conjugates right here, when you multiply the conjugates, you're going to have the first term squared minus the second term squared. So in this case, we are going to have square root of 3 squared minus 8 squared. When I do that, because now it is raised to a power of 2, the power and radical cancel, and we can get rid of that radical sign in the denominator. So this will be 2 square root of 3 plus 8. And then down here, we are going to have 3 minus 8 squared, which is 64. And then we can try to simplify it. Again, remember, the goal of rationalizing is to get rid of this square root, to get rid of this radical sign. If I just multiply it by a square root of 3, once you complete the multiplications, you will still have a radical in your denominator. But when you multiply it by its conjugate, you will get rid of all your radicals. That's why we do it. All right, so we spent half of the workshop just covering the things you are supposed
I'm sorry, I wanted to ask for that example that you were just doing.
Mhm.
So would we
Yeah.
continue to simplify, or would we leave the denominators 3 minus 64?
Yes, we have to simplify this as much as we can. So for the next part, you're going to distribute the 2 inside of this. So it will be 2 square root of 3 plus 2 times 8, 16. And this is going to be negative 61. Now, sometimes you can also factor something in the numerator. It might cancel with denominator, but that's not the case here. If I factor a 2, it will not be canceled with negative 61. So we are going to say this is the final answer. Usually, most of the times, professors just accept this as your final answer. All right. Any other questions so far? I know it's a lot of information, a lot of different rules. Was there any part that you didn't understand?
I think I understood most of it.
Okay, that's good. How about others?
I'm still trying to process it, Ava, but I look at the worksheets once we get off and just practice on the worksheet.
Yeah, that's a good idea. Yeah, we are not expecting you to learn like everything at the same time. Just try to make sure that you have a general understanding of it, and we can also do some examples. So as you can see, in any workshop, we are going to have some exercises, and the answer is down here. So let's look at exercises. Where is it? All right, let's look at question number 1. So from 1 to 14, which one would you like to do?
Could you do number 9?
Okay, we have number 9. There was another one too. Somebody said something.
I had said 7.
7. Okay, 9 and 7. All right, let's work on these two. So these questions are what we know as simplifying radicals. Basically, you want to write this as numbers as much as possible. So first, let's get started with 9. We can explain how to deal with these, and then we can do number 7. So first, we are going to have the 4th root of 48 y to a power of 6. So the idea of simplifying is that you want the radicands to have the same power as your index. When they have the same power as your index, power and radical cancel. You can just bring it out of your radical. That's usually the goal that we have. Now, how are we going to do it with these ones? For the numbers, I want you to write them as their prime factors. So if you don't know how to do it, we usually use what we call a factor tree. So 48, it can be written as 2 times 24. And then we are going to keep going until we have all prime numbers. So 24 is going to be 2 times 12. 12 is going to be 2 times 6. 6 will be 2 times 3. So at this point, this 3 is already a prime number itself. I'm going to stop. I say the 48 is going to be 2 times 2 times 2 times 2 times 3. These ones. So now I know all the factors for 48. Now, the way I would try to do it, try to write them in a way that they will have a power of 4. So in this case, it's pretty easy. It's already given to us. We have 2 to a power of 4, and we just have a 3. For y to a power of 6, again, I can't just cancel a 6 with a 4. It's not going to work out. So instead, I say, okay, what if I rewrite this as y to a power 4 and y squared? Again, if you think about it, I'm not changing this. When you multiply these two, it's going to be y, 4 plus 2, 6. I just rewrote it so I can cancel it. Once you rewrite all your numbers, all your variables, now you can start to do the canceling. So you're going to say, okay, for this 2, the power and radical can cancel, so you can take out that 2. For 3, it has a power of 1. It can't cancel, so it's going to stay inside your radical. Keep the 3 here. For this y, again, it's going to cancel the power and radical. You're going to bring out the y. And y to a power of 2, again, 2 and 4 can't cancel. So you're going to keep the y squared inside of your radical. And let's move this here. Now multiply anything that you have outside. You are going to get 2y times the 4th root of 3y squared. This is going to be your final answer. Did anyone sort of understand how we do it? Because that's what you have to do for all these types of questions.
Yeah, it makes sense. You're just like simplifying it down the most you can.
Exactly. So now let's look at this other one here. Question number 7. It's going to be the same thing, just a little more work, a little maybe more complicated. So first thing first, we have a cube root, 16 c to power 5, d to power 7, And here I have 250 c squared and d squared. Again, there are different ways of doing math problems. Most of the times, all of those ways work. For this one, I try to make it easier for myself. Instead of trying to write down all the factors for all of them, I say, let's just simplify this fraction a little bit. So if I try to simplify this one, I can actually simplify the c's here. This one completely goes away. For this one, if I remove 2 from it, I will have a c to a power of 3. Again, for the d's, I can simplify them. This one completely goes away. This one, if I remove 2 from 7, I will be left with 5. Now for 16 and 250, if you know how to cancel it, I know we can do it with a 2. Let's see if we can also do it with a 4. So 250 divided by 4. No, 4 is not going to work. So let's just divide both of them by 2. This one becomes an 8. This one becomes a 125. So what I did here, I'm not using any radicals. I'm not doing anything. I'm just doing a very easy simplification. This becomes square root of 3. In the top, I have 8. C cubed, d to a power of 5. And down here, I just have 125. Now that it looks much simpler and much more organized, we are going to write down their factors. So for an 8, again, you can do 2 times 4. 4 is 2 times 2. So 8 is equal to 2 to the power 3. For 125, you can say it's 5 times 25. And 25 is 5 times 5. So 125 is equal to 5 cubed. Now again, remember, the goal is to have numbers or variables with a power of 3 so they can cancel. This is 2 to power 3. This is 5 to power 3. We have c to power 3. So far everything is good. Now for your d again, 5 and 3 don't cancel. But if you rewrite this as d to power 3 times d to power 2, then it's going to work out. Again, 3 plus 2 is 5. That's how we know how to write it. So I'm going to write down d to power 3 times d squared. And then at this point, we just start canceling. So you're going to say this 2 cancels, so you bring it out. The c cancels, so bring c out of your radical. The d cancels. This d, the 2 and 3 can't cancel, so you're going to keep it inside your radical. And then for 5, it also cancels. Now remember, these ones, 2, c, and d, were in the numerator. 5 is in the denominator, so you're also going to put it in the denominator. And this should be your final answer. Okay, any questions about this one? I know it was harder than the first one.
When you cancel out the variables like c and d,
Mm-hmm.
so they don't just like completely disappear. You just write them outside of it.
Exactly. basically, when we are saying the canceling, the power and the radical cancel, but the variable is going to stay there. So it's like doing 7 squared. When you cancel the power and radical, you will just have 7. In this case, it's like having a variable instead of that number. Power and
Okay.
radical cancel. You just get C. All right. So let's move on to doing some operations with them. Let's choose one from here. So looking at question number 2, which one would you like to do?
I'd like to do number 4.
That's a really good one. So let's do number 4. We have 4 square root of 2 minus 7 square root of 25 plus 2 square root of 2 minus 2 square root of 8. So basically, the only operations we have are addition and subtraction. Can anyone remember how the radicals should look like if you're adding or subtracting?
Shouldn't they it's always minus? It's A minus B.
Yes, that's one point about it. And another thing about it is that they must be like radicals. So both the index and the radicand must be the same. So in this case, if I try to add or subtract, I can definitely add this one and this one. They are both a square root of 2. Can I add negative 7 square root of 25 with negative 2 square root of 8?
No.
Can someone tell me why?
Because they're not like radicands.
Exactly. So they are both the square roots, but the radicands are different. So to this point, I know that I can add those yellow ones, the highlighted ones. If I add these two, what is going to be the answer?
6 square root of 4.
When we are adding or subtracting, should we do anything to the radical? Let's look at here.
The radicand should remain the same, right?
That's it. So the 6 was correct. Yes, 4 plus 2 is going to be 6. But in addition and subtraction, you don't touch the radical. So you just write down square root of 2. But good job. You have an idea of what to do with. Now for this part, because we said we can't like add or subtract these two, we are just going to try to simplify them as much as we can. So for negative 7 square root of 25, what is the square root of 25?
5.
It's just going to be 5. So I can write it as negative 7 times 5. Now for negative 2 square root of 8, I'm going to write it here. Again, 8 is 2 to power 3. So let's see, this is the square root of 2 to power 3. Again, index is 2, power is 3. So I'm just going to rewrite this a little bit. Say this is 2 to power 2 times 2. This one and this one cancel, so I'm going to have a negative 2 from before. I already had that. You're going to bring out this 2. And then this one just stays inside your radical. So negative 2 square root of 8 is also equal to negative 4 square root of 2. I'm going to write it up here, negative 4 square root of 2. Now, if you look at it, okay, this is a square root of 2. This is a square root of 2. So now you can try to add these ones. 6 square root of 2 minus 4 square root of 2 is going to be 2 square root of 2. And then this is minus 7 times 5, 35. And at this point, there is just nothing else we can do about it. This is going to be our final answer. So this one was like a very good question, and also it had everything. Did anyone understand how I wrote -2 square root of 8 as -4 square root of 2?
Is it like because that's like the same thing? You're just moving around the numbers?
I did the same thing that we did up here with simplifying. I did it for 8. So you can say square root of 8 is equal to 2 square root of 2. Now there was also a -2 behind it, so -2 times 2 square root of 2 is -4 square root of 2. That's how we got that. You're going to put it up here. Once you do that, you can also subtract these ones, and you get this final answer.
So what is the square root of 2?
The square root of 2, you mean like the value for it?
Yeah.
So because 2 is not a complete square, if you put it in your calculator, it should give you a decimal number of 1.4 and then many decimals after that. That's why we just keep it that way, because it's going to be decimal.
So then you're doing -4 times the square root of 2, which is the same as -2 times the square root of 8?
Exactly.
Okay.
So this is going to be for number 4 again. Try to look for like radicals, add them to each other. We did it this part. For the ones that are not like radicals, try to simplify them. So this one became this. -2 square root of 8 became -4 square root of 2. You can still subtract these two. And this is going to be your final answer. We might have time. Let's do one from here, a quick one from here, a quick one from here. Let's say, Shinaya, can you tell me which one we should do from number 3?
Can we do number 3?
Number 3, yep. Let's do number 3. So this is going to be determine the radical conjugate and find the product of them. So first thing first, we say this is the number that they gave us. The conjugate is going to be the same thing, just instead of subtraction, it's addition. So it will be square root of 11 plus 2 square root of 3. Now, if we try to multiply these radicands, we are going to get square root of 11 minus 2 square root of 3 square root of 11 plus 2 square root of 3. For multiplying conjugates, we always say the first term squared times the second term squared. So our first term is the square root of 11.
And this is you using like the formula we're supposed to use generally?
Exactly. That's the formula for conjugates. So square root of 11 to a power of 2. The formula says there is always a minus here. And then your second term is squared. So your second term is going to be 2 square root of 3 squared. Now for this one, the first one is just easy. You're going to say power and the radical cancel. It will be 11. Be careful with the second one. So here you are having 2 square root of 3 to a power of 2. Every time there is a number in front of your radical and you raise it to a power, this power is going to be for both of them. So the power is going to be for this 2, and it's going to be for your radical. It will be 2 squared times square root of 3 squared. Now, when we try to simplify this, we are going to have 11 minus 2 squared is 4 times. Now, for this one, again, power and radical cancel. It's just a 3. So we're going to have 11 minus 12, which is -1. All right. How do we feel about conjugates? Did anyone understand it?
Yeah, I understood it.
Yes.
Okay, perfect. So one last part is going to be the rationalizing. Eureka, can you tell us which one we should do in this part?
Can we do number 4?
Number 4. Usually number 4s are going to be the hardest ones. So 12 over square root of 7 plus square root of 3. Again, if you remember, when you have just a single radical, you are going to multiply it by a radical, different ones. But when you are having 2 terms down here with a plus or minus, we have to use conjugates. What is the conjugate of this denominator? Can someone tell me?
Square root of 7 minus square root of 3.
Yes, thank you. Square root of 7 minus square root of 3. We multiply both numerator and denominator by that. So in the top, I'm going to have 12 times square root of 7 minus square root of 3. Down here, we are multiplying conjugates. Does anyone remember how we do that? We just did it in the last one.
You would just change. Go ahead.
Yep. Good. Everybody tells me what they think. Let's see which one works.
Wouldn't you just do the
Huh?
square root
Yeah,
of
just give me 1
7
second.
squared minus the square root of 3 squared, so it becomes 7 minus 3?
So square root of 7 squared minus square root of 3 squared. Does anyone agree with this?
Yes, I agree.
Okay.
Yes.
Yes. How about you, Eureka?
Yes.
All right. Well, that's correct. We say the first term is squared, square root of 7 squared, minus your second term squared. So now all we have to do is to try to simplify these a little bit. Down here, powers and radicals cancel. And up there, we have to multiply. So distribute 12 in your parentheses. Or actually, let's keep that for the last part. It's going to make it easier. So I'm just going to say 12 square root of 7 minus square root of 3. Here we are going to have 7 minus 3. 7 minus 3 is going to be 4. Now again, with rationalizing, always try to simplify as much as possible. In this case, 4 and 12 are going to cancel. We get a 3. Now we can try to multiply the 3 by the parentheses. So this should be 3 square root of 7 minus 3 square root of 3. That should be our final answer. All right. Any questions? Mhm. I'm sorry, can you say that again?
No, I just said thank you.
All right, you're very welcome. So this was our radical workshop. Again, you can always access these questions, these handouts on WC Online Canvas page. And they also have the final answers for you to check. They have videos that you can watch. If you still have problems with radicals, feel free to come to us for tutoring. We'll be happy to help.
All right.
All right.
Thank
So
you.
you're welcome. I hope you have a great weekend.
Thanks, Ava. You too.
Thank
Thanks,
you.
Ava. Well,
Bye.